Welcome to extra equation corner. So today we want to resolve this problem. We have x to the power of root y minus y to be equal to 65. So for us to begin, we know that 2 over 2 is equal to 1. So we multiply this power by 2 over 2 to have x to the power of root y further raised to the power of 2 over 2 minus y, or equal to 65. So this will give us, when we multiply the powers, we have x to the power of root y over 2 further raised to the power of 2 minus y equal to 65. But y is equal to the square root of y all squared. So we'll be replacing this with this to have x to the power of root of y over 2 further raised to the power of 2 minus the square root of y further raised to the power of 2, which is equal to 65. Let a be equal to x to the power of root of y over 2 and b be equal to root of y. So replacing these terms here, we have, replacing this with a, we have a squared minus b squared, all equal to 65. A squared minus b squared is equal to, we have a plus b times a minus b. So when we replace this here, we have a plus b times a minus b, all equal to, we have 65. So from here, since we don't have a negative constant, it simply means that a plus b is greater than a minus b, and also a is greater than b. Possible factors of 65 will be 1 times 65 and 65 times 1. We also have 13 times 5 and 5 times 13. But a is greater than b, hence this is rejected. And this is also rejected. So we have 65 times 1 as case 1. And we have 13 times 5 as case 2. So for case 1, we have 65 times 1. So we have a plus b times a minus b to be equal to 16 times 1. So from here we can get two equations to have a plus b to be equal to 65, to be equal to 65, and we have a minus b to be equal to 1. So adding the two equations, let's name this equation 1 and this equation 2. Adding these two equations, we have 2a to be equal to 66. So from here we have a to be equal to 66 over 2, and our a is equal to 33. So when a is equal to 33, we have a plus b to be equal to 65. So our a is 33 plus b, all equal to 65. We have b to be equal to 65 minus 33. So our b is equal to 32. But let's recall that a is equal to x to the power of root y over 2 and b is equal to root of y. So if b is 32, we have 32 to be equal to root y. So we have y to be equal to 32 all squared. So our y is equal to 1024. So we can impute the value of y over here, and we know that our a is 32, a is 33. So we have a to be equal to x to the power of root of y over 2. A is 33. We have 33 to be equal to x, and our y is 1024. So we have root 1024 all over 2. So from here we have 33 to be equal to x to the power of the square root of 1024 is 32. We have 32 over 2. So we have 33 to be equal to x to the power of 16. So x is equal to the 16th root of 33. Let's consider the second case. We have case 2, and we have 13 times 5. So we have a plus b times a minus b to be equal to 13 times 5. So we get the first equation, plus b to be equal to 13 as equation 3, and we have a minus b to be equal to 5. So adding these two equations, we have 2a to be equal to 18. So a is equal to 18 over 2, which is equal to 9. So when a is equal to 9, we have 9 plus b, all equal to 13. So our b is equal to 13 minus 9, and b is equal to 4. So we have a and b to be equal to 9 and 4. But let's recall that a is equal to x to the power of root y over 2, and b is equal to square root of y. So since our b is 4, we have 4 to be equal to the square root of y, and we have y to be equal to 4 to the power of 2. So our y is equal to 16. So imputing the value of y and the value of a here, we have a to be 9, or equal to x to the power of our y is 16. So we have root 16 over 2. So we have 9 to be equal to x to the power of 4 over 2. We have 9 to the power of s squared. So our x is equal to the square root of 9, and our x is equal to 3. So the values of x and y is equal to, we have the first one as 16th root of 33 and 1024, and we have the second value of x and y to be equal to 3 and 16. Thank you for watching Expert Equation Corner. Subscribe and hit the notification bell so you don't miss out on any of our solutions.